All right, welcome back to Thirst for Knowledge, where we drink and we learn stuff, and it's August.
Welcome to August.
And Ben, I gotta know, what are you drinking?
I am drinking a peridot martini.
Okay, what's in it?
It's got vodka, Midori, which I've come to love since we started doing this show, triple sec, and some lime juice. And it is quite green.
Very green.
And it's, like I mentioned just before you hit the record button, it smells like a really good idea. I can't wait to try it. What are you having?
I also have a peridot, and I guess it would be a martini. It's gin and vermouth and chartreuse, green chartreuse, and a little bit of orange bitters. And it's not quite as green, but it's all right. Cheers.
Cheers. Let's drink our liquid kryptonite.
All right. That's not bad.
Oh, what a good idea.
Mine definitely has that like very floral, herbal, gin, chartreuse kind of vibe going on. Can work with that. So
that is good.
Yeah, birthstone for August is a peridot.
A peridot.
Is that how we say this? Are we agreeing on that? Peridot?
Well, is there another way to say it?
I know it's not like some weird French pronunciation, like peridot or something like that.
Let's see. From my reading, it either has an Old French or possibly Arabic original or origin for its name. French is the closest for peridot in as far as spelling goes. Peridot, P-E-R-I-T-O-T.
It would be peridot.
But
French don't pronounce an N syllable unless there's like an E after it. So you wouldn't pronounce the end T.
Fine.
I know, I'm being pedantic.
No, you're just being more educated in the ways of speaking other languages. And Arabic, it's a faridot, which means gem. So
I know that peridots were highly prized in ancient Egyptian society. They were mined in a Red Sea island, and they're called the gem of the sun.
Yes. Let's see. I have a note about that. It was where did it go? Oh, Cleopatra was a fan of them.
I feel like she was a fan of anything sparkly.
She was a fan of anything sparkly.
Yeah, I'm getting that vibe.
Not as much as the previous stone, which we covered, which was, golly gee willikers, in which she was just ridiculously a fan of rubies. Yes. But she liked them very, very much. So much so that island was kept under strict military guard.
So nobody else could get them.
Maybe just to control it. It was on the island. What was it? Sabagard?
Yeah, definitely not pronouncing that correctly.
I'm not pronouncing it right. I'm not very good at pronouncing things.
I have that they're also called the evening emerald.
Oh, I did not see that in my my little reading of the evening emerald.
Yeah, I kind of liked that. And that because, and we'll get into the, how they're formed, but because they come up via magma, in Hawaiian culture, they once symbolized the tears of Pele, the lava goddess.
Oh, that's beautiful.
Yeah.
I love those types of stories.
I know, I do too.
But yes, they are formed deep, deep down in our mantle.
Yes.
About 20 to 55 miles below the surface. And if you see a volcano, peridots are brought up that way.
Yeah, it's super cool. So they're actually gem quality olivine. And olivine is a really prominent mineral in the Earth's mantle and actually in some of the Earth's crust.
And found on the moon.
And in meteorites. I got some fun space facts for you on this one.
We'll get there. We'll
see if we'll have the same space facts. So they are magnesium iron silicate.
Yes.
And this is important. It's the magnesium and the iron. And very interestingly, I think this is one of the most interesting things about peridots is that the color does not come from a chemical impurity. It comes from the crystal structure itself. And that's why peridot tends to look the same color green day, night, lighting. Although I have a little interesting paper about that later, but I thought that was kind of cool. Like there's no impurities, it's just green because it's green.
Also, the size of the peridot, the larger the peridot, the deeper the color the peridot can be, which I find very interesting because, as you said, the color comes from the crystal structure itself. So the more you have of it, the more it will kind of marvel out at you.
And I am wearing a peridot this evening. It's one of my mother's, and mine is like very chartreusey, so like a yellow, pale yellow green kind of color. But it goes all the way like through almost the entire green spectrum, I think. You can find
That's
peridots. Awesome. So we said they're found in, I learned 2 new vocabulary words for us. Ready?
Ooh. Let's do it.
Mafic or mafic and ultramafic igneous rocks.
Okay.
So igneous rocks are formed through the cooling and solidification of magma, like we've said. Mm-hmm. The mafic or mafic part is that are rocks that are rich in magnesium and iron and relatively low in silica, and most are dark in color. So these are where olivine is found, and peridot is just translucent olivine, which I thought was kind of cool. And they have really high crystallization temperatures compared to other minerals. So it's one of the first minerals to crystallize from magma.
Okay.
Which I thought was kind of cool too.
You mean when magma cools in general, it's one of the first minerals to crystallize from that? Or
yeah. So
it's one of the first minerals to ever crystallize in magma on this earth that we know of?
The first option. So as it cools, it has a higher crystallization temperature. So as it cools, it's going to be one of the first minerals that's going to drop out in crystalline form as the magma slowly cools.
Awesome.
Yeah.
Yeah. Just makes magma all the cooler. First,
I mean, it doesn't need help. It's cool already.
Yeah.
Have you been following Kilauea? Has been erupting in Hawaii.
I saw.
Very cool footage.
Maybe they're getting some new stuff. Yeah. Some new peridots.
So, can we talk about the space stuff yet?
Well, I have. Where's my? I want to get there. As I'm trying to dig up my space stuff, some extraterrestrial information about peridots.
But while you dig it up, I have a fun fact.
Sure.
So, olivine, this mineral that peridot is a type of, is considered the ideal rock for sauna stoves in Finland because it is comparatively high density and relatively resistant to weathering under repeated heating and cooling. So, peridot saunas.
Sounds pricey, but okay, I would go.
Well, have you ever been to one of those day spas where they have like all the different saunas and like one is charcoal and one is salt and there's always like an amethyst one? Just have a peridot one.
Never even heard of it.
Oh, they're great.
The salt ones and the charcoal ones, and also just some sauna that I don't even know where the steam comes from, but it's there.
Okay, space peridot.
Let's go to space peridots, extraterrestrial peridots.
All right. What do you got for me?
There is a series of what they call space gem discoveries. And peridot is found in a whole bunch of meteorites that have landed here.
Yes.
There's the Esquel meteorite from Argentina and the Fukang meteorite in China. These things were formed like 4.5 billion of years ago, and they're older than the Earth. And
cool.
And they're made of the exact same type of material that is generated by the mantle today, same peridot material. And some of these things are so interesting that the Fukang meteorite, as an example, the one that landed in China, it had olivine and peridot crystals that were of substantial, you can hold it in your hand size, of gem quality. These things are just tumbling around in the early protoplanetary disk that eventually became our solar system, these gorgeous little green gems, and then just by happenstance,
just tooling around,
a planet formed and it got in the way, and boom.
So there's a name for them, pallasites, as part of an asteroid or planet that was near the mantle core boundary, where rocky materials of the mantle were mixed with the metallic materials of the core. And so they usually have these distinct crystals of olivine surrounded by a nickel iron matrix, which is cool. Like, you think about it, it's like part of another planet's or would-be planet. Like, so one theory I saw was that some of these asteroids or meteorites originated from a rocky planet that used to occupy the orbit between Mars and Jupiter. So it's cool. Like, this used to be a planet and it broke apart for some reason, and then like pieces of it are now falling to Earth that contain this structure, these pallasites, but that are very similar to what we see here on Earth. It's kind of neat to think about.
Maybe there's like an ancient space battle fought over this planet that was rich with gems, and they just blew it up. And and that's what happened.
Did you find a little fun fact about NASA's Spitzer Space Telescope?
No. Man, your research is so much better than mine. Go.
Well, I do sort of have a professional degree in research. So.
Yeah, there's that.
So in 2011, the Spitzer Space Telescope observed what is thought to be tiny crystals of olivine, or peridot, raining through the dusty cloud of a gas of a developing star.
Love those stories.
So this is thought to have occurred as strong air currents lifted the newly crystallized olivine from the surface of the forming star high into its atmosphere and then drop it, and then it would drop again when the currents lost momentum. So it would rain these beautiful crystals of olivine into this newly forming star, which I thought was the coolest image, and I should have AI generated something. No, I should not have AI generated. I will ask you to actually generate something because I feel like it's a cool image, right? Like,
that is a cool image. I mean, there are, we suspect on planets in our own solar system that it's raining diamond or glass.
Yeah.
And, or just molten metals of different kinds. But but that sounds interesting because that's a bit more complex than just a diamond, which is carbon. This is a combination of minerals.
Yeah, but if you think about sort of that nucleus of a star being formed, right? There are supposedly a lot of heavy metals and things that get sucked into that gravitational pull that are part of that formation. And so it would make sense that some of them would precipitate out and make these beautiful crystals that would rain back into the star.
That's awesome.
And as we know, if you're not the part of the solution, then you're the precipitate. Science
jokes. I love them. I love them. I was going to say that seeing how olivine and peridot have been found in the orbit between Mars and Jupiter, a little bit closer, olivine and possibly peridot have been found on the surface of Mars by the Mars Global Surveyor.
Cool. In
the Nili Fosse region. So it was the first gem actually discovered on another planet.
That's so cool.
It's been found on the rocks on the moon, but on the planet Mars is the first. So we actually found some green goodness.
This is great research. You found things. I found things. This is why we're,
Go team.
Yeah. So peridots here on Earth. Let's go back.
Let's start there.
Yeah. So we've talked before in our podcast about gemstones that are treated, but apparently peridots are hardly ever treated. Just sometimes they're occasionally enhanced with colorless oils or resins to reduce the visibility of inclusions. But pretty much like what you see is what you get with them, which is kind of cool. And I mentioned that they should display the same color regardless of lighting. Right. However, a intrepid team of scientists in China took peridots from China, Pakistan, and Myanmar, and they used neutral gray backgrounds. I did not know this, but there is something called Munsell backgrounds, and it's a grayscale fan deck. You know how you go to Home Depot or Lowe's and they have all the paint swatches? Yeah, it's kind of the same thing. But it's in quarter step intervals of color, and it's used for instrument calibration. Yeah, I'm sure woodwinds love it. But these are standardized so that each shade is the same difference from each other as the one before. So it is a actual graduated scale, and they're used for instrument calibration and image testing and stuff. So anyway, so this team took these various different peridots and they put them against the gray backgrounds and they put them against gold alloy backgrounds, and they use one of my favorite things, which is spectrophotometry, which measures excitation wavelength and to assess the color. And what they found is that Munsell natural gray background N9 was the best for grading the peridot's color. So it does matter how you look at a peridot. Not so much the lighting, but more like what's behind it.
There is an inclusion or a defect, I guess you can call it, crystalline defect in the peridot that is called, they're referred to as lily pads.
Aww.
And it's adorable. And the reason they call it lily pads is because they kind of look like a lily pad with a dot in the center and surrounded by a flat circle that radiates outward from it. The way it happens is during peridot's formation, a little tiny crystal or a little type of itty bitty impurity gets trapped inside the growing olivine crystal, which eventually becomes the peridot. And as the host crystal starts to cool and decompress during its ascent towards the surface, it creates tension cracks around that little spot where the inclusion is, and it just cracks equally outwards from that into a nice little circle. And they're small, they're not that big, but it's something that people look at. If they can see them, it's a sign of that they are real, or at least that they're very, very old and took a long time to create. And some people actually like them. They prefer them. They want to see lots of them because it's just a pretty little artifact. And they're very unique. So they're often you get a peridot and you map the lily pads that are inside of it, and it forms a kind of like a fingerprint for that particular gemstone. So
that's awesome. Do you think they're call it lily pads because they're green?
Well, the item is green, but the lily pad's shaped like a lily pad, which makes sense.
But we all know it's not easy being green.
It's love you, Kermit. Yes, it's not easy being green.
That's really cool, though. It's interesting. We talk frequently about inclusions and sort of perceived defects in these stones, and I don't know. I just think it makes them more interesting, personally. Although I know potentially for grading purposes, they're not as valuable with a bunch of flaws in them.
No, but yeah. And it's also very common and it can be found everywhere. And for the longest time, people thought they were emeralds, but then, So peridot has something called a very strong, I'm going to say this wrong, birefringence.
Okay.
Birefringence means sometimes you see a faceted edge on top of itself, like it's repeating.
Oh.
And because it's an optical property of a material having a refractive index, depends on the polarization and propagation direction of light. And birefringence has double refraction. So when you look at it from the side, it looks like one facet of side is sitting on top of itself. And it kind of has this weird...
See, now I have to take my necklace off and see if that's true.
Some weird ghost-like effect of another side directly underneath each side.
Huh. That's really cool. Mm-hmm. Does it have to be out of its setting to do that?
I don't know. I just know some of them have it very profoundly and some not so much. But the fact is,
so I'm supposed to see like two facets?
You're supposed to, when you look at each facet of the cut peridot gemstone, you should be able to see in some situations, I guess, a kind of almost ghost-like repeat of the facet that you're looking at.
Oh.
Like it's reflecting almost off of itself.
Interesting. Yeah, maybe.
Something worth while if you have a loop or a magnifying glass.
Yeah, I think I would need a magnifying glass to see it.
Microscope or something. It's to be fun to...
Do I have a microscope?
I got a giant one right behind me. I'm going to go...
I have one from the 1800s, which...
Okay, you win in the nerd contest. You win.
I don't know. I mean... Oh, actually, I have to fix my... It was a gift. So there wasn't a ton of research on peridot, but I did find that a research team experimentally shocked deformed a single crystal of natural peridot, and they used transmission electron microscopy, another very fun tool, by the way. And what was interesting is what they found was what they think is the first example of olivine glass.
Ooh.
Which suggests that olivine glass may be formed as a result of shock at high pressures naturally. So shock deformation is supposed to mimic events like a meteor impact with very, very large amounts of pressure. So for this study, they used 56 times 10 to the 9th pascals, which is 550,000 times greater than normal atmospheric pressure at sea level, and significantly higher than the pressure at the bottom of the Mariana Trench, but is equivalent potentially getting close to the pressure you would see in the mantle. So there's a good chance that olivine is in a glass, or some sort of olivine glass does exist in the mantle of the planet.
A, it's awesome. And B, you're telling me that the pressure in our mantle is 550,000 times sea level's atmospheric pressure?
At least. Probably a bit more, actually.
Wow. That really...
I mean, this is how diamonds
I know on Venus it's like something like 90 times and you'll be crushed instantly.
Oh, yeah. I mean,
this is ridiculous. That makes Venus look like, nothing. Oh my goodness.
So, I mean, that's the equivalence I found online. May or may not be correct. But the actual statistic from the paper is 56 times 10 to the 9th pascals.
Hey, math don't lie.
I mean, I didn't do the conversion personally, not my area. But I do know that you can achieve rather significant amounts of pressure sort of above and beyond what you would see kind of naturally in the earth with things like autoclaves and stuff like that. Like, which is why when I was working in the lab, I would set the autoclave. So we'd use autoclaves to sterilize our glass lab equipment. And what it does is it has very high pressure so that you can actually get the temperature higher than you would at like normal sea level. But I would set the autoclave and like run for my life. Not that it would have mattered, because if that autoclave went, it would have taken out the whole building with it. But just like the idea of what was going on in there, I was like, I'm out of here.
Anybody thinking about getting a job or pursuing study in science, please do. That just sounds awesome.
It's funny. It's interesting. Like when you talk about it, it is awesome, and it's awesome in many, many ways. And it's marked by large stretches of sheer, not even boredom, frustration. Like things don't work, and you can't repeat an experiment, and the instrument breaks always at 5 p.m. on a Friday when there's nobody there. That kind of stuff.
That's crazy.
Yeah. That is what I had for peridot. Do you have any additional fun facts you'd like to share?
I do. It is possible to make lab-grown peridot and lab-grown olivine, but there's no real reason to do so because it's everywhere. It's not hard to find. It's not incredibly, but it's one of the softest as far as the Mohs hardness goes for gemstones.
Like 6.5 to 7.
Mm-hmm. Yep. So it doesn't really have any industrial uses like previous stones we've mentioned.
Olivine does. So olivine itself does. So you can use it as in some of the steel processing, but also in aluminum molding. So instead of using silica sand in the mold, you use olivine sand because you don't need as much water. Yep.
Foundry sand is what I found it's got to use.
Yeah.
And do you know what one of the largest peridots in the world is?
I do not.
Has the record of the largest cut peridot in the world. It's around 310 carats, and it's housed at the Smithsonian Institution in Washington, D.C., and it is called the Smithsonian peridot. So you can go look at it. It's gorgeous.
This begs a bigger question of when you're going to come to DC and we're going to go to the Smithsonian so we can see all these things that we've been talking about. Thirst for knowledge field trip. Thirst
for knowledge field trip, but I just won't leave. I'm just going to stay there. Gosh. And there's also the Zabargard St. John's Island crystal, some of the largest peridots ever found. Hundreds of carats each before cutting, and there are many Zabargard crystals, but there's one that's referred to as the Zabargard crystal, and it was shipped to England. I should have brought this up when we did diamond, very similarly to the Cullinan diamond. The Cullinan diamond and also when the Zabargard crystal was shipped to England, it was sent in a sealed trunk under guard in a flotilla of ships, and that was the fake. The real one was just put in a cardboard box and insured up the wazoo, and just sent to the post, and they had a secret code written in the name of the recipient who was getting it at the end of the road.
That's cool. I like that. I wonder if there are cursed peridots like there are cursed diamonds.
Okay. So what we're going to do now is we're schedule a Halloween episode because that sounds perfect.
Yes.
Oh, we should do that because this is our August episode. The next one's going to be for our October episode. We should also throw in.
Or just do an extra bonus episode, Cursed Gemstones.
There's so many cursed stories.
There really are.
There's so many. He was healthy and strapping young man until he got hold of this rock and all of a sudden his toes fell off or something like that. I can't wait. That'd be great.
Good idea. All right. So I have to say, peridots ended up being more interesting than I think I gave them credit for. And that was my mistake.
They are. They're great. They're green. I love green.
Yes.
The drink's tasty. I love tasty.
There you go.
And they're freaking extraterrestrial peridots.
Space rocks. Yes.
Space rocks. What color are space rocks, people, you're wondering? You think they're all gray dirt clobs out there? No.
All right. So thank you for listening to this episode. If you like it, share it, subscribe, give it a 5-star review. All the things.
Oh, please.
And I have been neglectful, Ben. I have not reminded people to always drink and science responsibly.
Please drink science responsibly.
All right. We'll see you next month.